first one is David Finn, if you could come up, the CEO from Gillon. Thank you. And the next is Adrian Duque, who is the National Business Development Manager in charge of EV charging solutions at Schneider. Thank you, Adrian. Chris Thomas, whose electrification business, ABB, is going to join us. Thank you, Chris. And Aaron Gillon, the Divisional Manager, YHI. All right, we're talking hardware, but first of all, we'll do the usual. If you can just briefly say something about yourself and your business, what your role is and what your business is contributing.
Yeah, well, as one of the founders, I've been doing this for a fair while, so I've been doing EVs since 1999, actually.
This is David Finn.
Race solar cars across Australia, so I've been involved with motor drives and all sorts of weird and wonderful projects over the years, and ended up finding our way into EV charging. In the last 4 years, we've seen some significant growth. And it was about 2012, I think, when I first started interacting with ChargeNet. And Steve came over and was out the front wobbling the charger around, making sure it was strong enough for what he wanted to do with it, and made the decision to start rolling it out through New Zealand. And in that time, we've seen uptick of EVs in New Zealand, well past Australia. I think we've got double the number of EVs here now.
That's interesting. We're fast adapted, so adopters as well. But what about Tritium? What is its whole raison d'être?
Look, we're all about cleaner and healthier cities, and doing that in a way that's more convenient for drivers. So we're out there making hardware, software, and services. We'll talk a little bit later about SLAs, but we're really building that out now and been able to actually turnkey that as much as possible. We're seeing a real convergence of industries here: big oil, utilities, automotive, and startup companies with some pretty good backing coming into the space, and really finding real estate to put charging infrastructure around and make sure that people can drive everywhere they need to go and use their electric vehicle in the same way they use their petrol-powered vehicle. And we're seeing, and you look at the forecasts, and they all sort of top out about 50% EV penetration, because they're assuming that you can only charge at home and workplace, and we want to get rid of that limitation. We want 100% of people in EVs, so that's the big thing we're trying to achieve.
Do you think we can do that 1.5 in the time? Do you think it's doable?
I don't know about that, actually. I'm really focused on making sure our cities are really clean and healthy.
Well, that's obviously going to help.
Yeah.
Now, Adrian, if you could just talk about your business and what you do there.
Good afternoon. My name is Adrian Duque. I look after the EV charging solutions for Schneider Electric. I've been with the company for probably 15 years now, 5 in the Philippines and 10 here in New Zealand. Probably moving here would be one of the best decisions I've made. Also, focus for us, for Schneider, would be energy management. That's all our business is all about. And EV chargers is a part of it. But as part of my role, it's not only about offering EV chargers, but more of the solutions. I'm not sure if you're aware, but Schneider Electric does a lot of things in terms of electrical. So when I say solutions, aside from the EV chargers, we're also talking about the protection devices, probably busway systems to power EV chargers individually. And also one of the things that we're focusing on this year, or even next year, would be more on the load management system side of things, trying to address some of the issues that we have in terms of electrical capacity.
Interesting. And you're a passionate mountain biker?
Yes.
And you have a new kitten. See, we do our research here. Hey.
That's the first one.
Okay, thank you so much. And now, Chris, if you could tell us about
Good afternoon. Chris Thomas from ABB. Been with them for about 11 years in Australia, UK, and a couple of years back in New Zealand. So ABB have 4 businesses globally, and one of those businesses is the electrification business, so I head up that in New Zealand. And part of that portfolio is of course the electric vehicle infrastructure that we and charging infrastructure, but also, and very similar to Schneider Electric, of course, as a global manufacturer and solution provider in the electrical industry. We're seeing more and more focus, and we collaboration day. It's about load management, of course, of electric vehicle infrastructure. The more we put in, the more we have to balance these loads, and we need to compensate for this. But it's about understanding the total load of a building, not just adding and overlaying some new power requirements for an electric vehicle charger. If we're just going to ignore what the building's consuming already and not try to do anything about it, then we're not going to optimise what we're trying to do. So ABB, that's really where we're focusing on over the next few years, is incorporating the EV charging requirements, but really looking at the buildings today and what they have. And we're not talking about just new builds, existing buildings today, whether it's in efficiency through insulation, or whether it's building control through lighting, through air conditioning, blind control, using the sun to heat and to cool the home as well. All of these technologies, they're not used together and stand alone, which traditionally is what we've seen with technology being coming into the market. We look at it as a standalone technology, and whilst that might be applicable in some sectors, certainly in the building sector, the places where we work and where we live, we need to look at the entire building infrastructure, not just overlay new power requirements for electric vehicle charging onto it.
Let's dig a little bit into that. So give me a building where everything's beautifully coordinated, how that looks, compared with one where everybody's in their own little silo.
Absolutely. So, I mean, there's lots of case studies already available worldwide and in New Zealand as well. And for quite a small investment, we talk about rate of return and the total cost of ownership and things like this. Just putting some very basic smart technology into a home today can reduce your power consumption by 20-30% very quickly. Now, if we talk about how much power has been talked about earlier today about putting solar, whether it's going to be hydro, solar, wind, or whatever it may be. So we talked about solar on individual rooftops. You know, so we mentioned 8 kilowatt this morning. I don't agree with that number. I think if you look at the worldwide installation of home solar, it's much less than 8 kilowatt. And most of those, well over 95% of those installations today have no battery energy storage. So we're not collecting, what we're actually generating during the day isn't being used. If you're not there, it's not being collected, stored, it's therefore not reusable. And we're really looking at microgrid technology. So yes, we could have everybody have a solar on their roof with a little bit of battery energy storage and their own inverter. Is that really that efficient? Or should we look at centralized systems? Today, you know, we've got a centralized grid. We need to go to a decentralized grid. So part of that is microgrid technology. And rather than having 1,000 homes with a 3 kilowatt inverter for the solar, why don't we have 10,000 homes all delivering from their own rooftops into a central inverter system of say 1 or 2 megawatts, and then sharing that out so we have the battery storage of 1 or 2 megawatts. So it doesn't really matter, and it's a shift in behaviour. It's human, of course. If you go to a person who wants to build a new home today and you say, okay, I want you to put 5 kilowatt of solar on your roof, but you won't have access to that solar that you generate. Well, of course, well, that's ridiculous. I'm paying for it. What do you mean? But if everybody puts it into a central inverter and battery energy storage system, everybody, 10,000 homes, would have a lot more than 5 kilowatts to consume. Because not everybody's home at the same time, but we store everybody's power that's being collected on everybody's rooftop. And now if you incorporate EV charging, fast charging into that technology today, now everybody's suddenly got access to much faster charging rates for electric vehicles, as well as, of course, at home. But we're delving into a micro system where we generate more than anybody will ever need, and it's much more efficient.
But if it's going to that centralised body, is there also room for me as the homeowner to sell that excess power?
Of course,
yes,
if it's a centralised system,
so
with 1 megawatt that you can contribute to,
yes,
then that centralised system can go back to the grid.
Yeah.
Of course, we're not talking necessarily microgrid off-grid, not necessarily at all. We're talking of that type of technology and system in those sectors, but still being grid connected. And the reason we want it to be grid connected, not because we need to consume from the grid anymore, but we can flow back to the grid.
Brilliant, brilliant. For the greater good. Thank you. And Aaron Gillon, could you tell us about your business?
Aaron Gillon, I'm the divisional manager for a company called Y&Chi. We're part of a large global company which actually manufactures wheels and tyres of all things.
Are you inspired by Eva's wheels?
Oh, yeah. That is a conversation. But yeah, in New Zealand we're a little bit different because of course in New Zealand we have to do things differently if we want to be successful. So we started a energy division about 12 years ago, and I head up the energy division. And in that energy division we distribute things like solar, we do panels, we do inverters, we do battery systems, UPSs, substation charging systems, batteries, and more recently EV chargers, which we sort of fell into by mistake 5 years ago. And that's been a huge growth platform for us, and it's actually helped us sell other products within our portfolio because they are so complementary. You know, particularly when we start talking about the solar and the batteries, you know, we're doing off-grid EV charging systems now, powered completely by the sun with solar carports. We're doing grid-connected hybrid systems and things like that. And I think it's a really cool shift. You know, we look at all the EV customers we have are thinking about PV, and the PV customers are thinking about EV. That's really...
It's beautiful, beautiful synchronicity. Let's get back to you, David. You mentioned SLA, service level agreements. Can you just talk about that and the importance of them and how they fit in here?
Yeah, it's something when we entered the business we didn't really think much about, and then as we started selling to people on the other side of the world, started to realise we have to actually build out capability to support these products in the ground. It's not something you just pick up and send back easily. So we've done that slowly and surely over the years, and now more and more of our customers are asking, so look, we'll pay you, but we just want to make sure that you guys turn up within a certain period of time. Make sure this charger's up and running again, and whether it be a warranty problem or whether it be someone's hit their charger or pulled the cable off or vandalised or something, it doesn't make a difference. We're there to resolve it. And when you connect that with the software platform that we've been building out to actually monitor what's going on and be able to go to site with the problem already diagnosed, that helps with that whole process. So it's something we're really looking forward to building out that part of our business, and we're doing that right at this point in time in Europe.
Wonderful. Any other panel input on that?
Yeah, I'd like to add on that, and I think SLAs is probably one of the things which is still lacking a little bit in New Zealand around that infrastructure. I mean, it's something we've been very familiar with in the UPS space. You have a system go down to the bank, somebody wants it fixed within 4 hours. We don't have that really happening on that same sort of scale yet, but it is becoming more important because we can't leave people stranded on the side of the road because an EV charge is fallen over.
And it's not happening because we don't have the numbers of people trained in that area. Is it as simple as that?
Well, I think it's about density. Actually having enough chargers out there to have a business model to support having those people on site and on call. But also a lot of it's about education. We're very big on trying to make sure that all the people we deal with, all of our installers, can diagnose and repair these things. Because we can't necessarily fly somebody down to Nelson at 2 o'clock in the morning to fix a problem.
Where is that training done, Aaron?
We run some training on our products internally, as well as we've got 8 branches around the country which we help do those trainings for our electricians and other people who are interested in that servicing space, as well as we can take them over to the factories if they want factory level training.
Should this be on a national level and special courses and churning out people who can work in this industry, or not just leaving it up to
well, it is very much about the manufacturer training, electrical technicians on their products themselves. So it's very product particular.
Specific,
so yeah,
right.
and we've just established offices in Amsterdam and Los Angeles, so now that actually helps us have training capability in those areas which we didn't otherwise have before. So that makes a huge difference, being able to bring people to your facility and show them through exactly how the product goes together.
Right, so it does fall on the manufacturer. Any questions from the floor? Yes, I'll take this one if you don't mind, or we'll just have to share on. Stand up and say your name and business.
Alan Chapman from Duque Technologies in Christchurch. I've spoken to most of you around the table today, so thank you for that. Big question is around bidirectional charging. Where are you respectively at in the 5 to 50 kilowatt bidirectional charging market that's going to come on stream in a big way?
Aaron, we'll start with you.
We've actually got our first engineering samples on the way down at the moment. We'll actually have them here next month for testing. They're coming down along with the model which is getting sent through to Australia for ASNZS certification. I mean, this is one of the things which is holding up a lot of these projects now is the regulation and the safety aspect. That takes 3 months worth of testing before we get to bring a product to market.
I hear a bit of frustration in your voice. Could it be done a lot more quickly? Is that just inefficient? No, look, it's just the process. There's so many products which are coming out there and so few test houses which can actually do this detailed testing. For us, it's a little bit different because ASNZS has some different requirements around grid-connected inverters. And us being a fairly small market and the low penetration into Australia means we probably don't get the same focus that Europe and the States do. So with this inventiveness we talk about today, do we need more of these testing houses, maybe government sponsored? What do we need there? Possibly, but they may not. I think we've got plenty of testing houses out there, but getting them sped up on some of these EV standards would certainly help with putting things along, but also getting the manufacturers buy-in to throw it into our market early would also help. Let's go back to the original question. Can have you got input on that one?
No.
No. Anybody else would like to say something on that question?
Yep. For Schneider, currently we don't have those technologies yet, but we do keep an eye on the market and what the market wants. So at the moment we're designing new offers that would come out probably in the next few years. I wouldn't say when, tight-lipped at the moment, but all I can say is that all of those technologies that would be needed now and also in the future would be part of our new offers eventually.
So you're similar to me, no then? Because I can't speak about it at the moment.
And David, do you have anything to add?
I was just going to say, I mean, it's technology we have. We are very focused on that mission of providing that energy freedom to everyone out there. So, and you know, I see the bidirectional piece as a secondary piece to that. I think it's more important for us to really make sure that public infrastructure is there on scale and people can just charge up and go as far as they need whenever they want. And I really see some really interesting stuff in the future, but the challenge for us is just getting the timing right, because the vehicle manufacturers, I'm only aware of 3 cars, the Mitsubishi, the Nissan, and now the Honda that does bidirectional capability. Now, there's technical capability in all the other vehicles, but the vehicle manufacturers haven't said they're going to support that yet. So it's maybe a few years away to really get some mass market.
Not just in vehicles, but in off-grid storage.
Yeah. Secondary life batteries, is it? Yeah, yeah, I think that's really interesting.
Thank you. Any other questions? Thank you for that. Thank you. Any other questions from the hall? David Slack.
Thank you. I have a quick question for you, Chris. Is 10,000 for the microgrid an arbitrary figure, or is that your optimal level? Is it sort of predicated on the size of the battery?
Not really. I mean, it was just a figure plucked. I mean, I'm talking to developers at the moment. This is really where it's come from New Zealand. So we've got some developers that we're talking to today, and they're looking at new subdivisions. And typically, it's between 7,000 and 10,000 homes. So what do we need to look at for a centralised system to support, say, 7,000 to 10,000 homes? And when we had a little bit closer look into that, and this is where it becomes this behavioural shift of 10,000 new homeowners paid, say, $5,000 for solar on the roof, but not being able to access it, seems a very, very difficult sell. But when you explain it to them in that situation where then it's 1 or 2 megawatt storage within that subdevelopment, so it's a gated community, for instance, and now we've got, obviously, transformers. So these are already off-the-shelf solutions that we have today from ADB. A containerized solution, so we can start with 1 meg, we can add another container for 2 meg. Inside these containers, you've got your transformer and medium voltage that will connect straight to the grid, so we're not off grid. We have 1 megawatt storage of batteries within these, all the inverters are in there, and then on the same skid we can have 4 50 kilowatt fast chargers, or we can have a couple of high power 175 kilowatt chargers. So that's really where those numbers came from, so the developers that are looking at today in New Zealand, and what would we need to provide for those size developments. So that's really where that number came from. But even if you extrapolate it out, you know, when we talk about 8 kilowatts on somebody's house, and you call that 10 kilowatts on somebody's house, but or you've got 1 million watts sitting down on the same development, it doesn't make any sense to try and recreate what we've done in the past by everybody putting a couple of kilowatts on the roof, not storing any of it. And you know, we all know that the payback into the grid, those days have gone. And lucky if you within the early days signed up a contract with a utility company for 30 years, and yes, you know your payback is good today. But those days have gone really, and we need to look at how we're going to store it ourselves efficiently. And of course, there's always going to be great applications. A lot of applications where we do need a single dwelling with something with an inverter and individual storage. Of course we do, and there's lots of companies, including ABB, that are delivering those in an affordable manner today. But I truly believe that the future is everybody feeding in individually into much larger systems. And when we talk about the grid and the peak demand and bi-directional for cars back into the grid, of course. There's an argument, there's a discussion to be had here, but when we're starting to talk about individual homes plugging in a car that may be 50% charged and whatever the battery capacity is today, or we talk about 2 megawatts sitting on a subdevelopment that the utilities can tap into and start taking 2 megawatts of power out of there to prop up on peak demand, the whole scenario changes. You know, trying to get 10,000, 20,000, 1 million people all acting in the same way, in the same time frame, is going to be a challenge, I assure you. But we start building these centralised systems, utilities get much more benefit out of it because the amount of power that's being stored in one location they can tap into any point in time would be much more beneficial to the grid for peak demand than it will be individual.
And the other question I had in mind, I think you've partially answered it, is do I take it that means you see this as grid plus, really?
Absolutely, yeah.
Right.
You know, we can go to certain places in the world. Islands are a very good example of this, where the infrastructure, electrical infrastructure, is very, very unsecured, for a better word. And then a true micro system is really the answer. We've got lots of case studies where it's completely off-grid, and these micro grids that have been set up have been running for 2 or 3 years, and there hasn't been a blackout yet, and they're not connected to any grid. They work.
Thanks.
Thanks, David. And that gets back again to that 2040. Have you seen it with Bangladesh? Yes, that's brilliant. Those microgrids. It's a brilliant idea. Anybody else with a question? Oh. It's nice having you here. You enrich the conversation.
Sorry, Rob Baker again from Victoria. Hey, look, it's a question really for Chris, because he's talking about the centralised storage and the processing. So what sort of CapEx and OpEx ratio per kilowatt? You're talking about a difference between going on a sort of 1 megawatt scale and going on an individual per house.
It's a difficult one to answer because it depends on what you're providing with the battery storage and the inverter system. If it's just a simple inverter and a battery store and batteries, and there's a cost to that. If we want to start looking at other technologies like electric vehicle charging to be added onto that, then there's a cost. We've done some pilot studies and we're doing some pilot investigations with large groups like Ponterra, for instance. It's no secret. And we're looking at a particular pilot site for that today, and that's in the region of 3 megawatts, and it's in the millions, obviously. But when you consider that the other option to provide this power to these plants in these locations is new substations with the price tags of $6+ million, it starts becoming somewhat of an attractive alternative, and it's new technology, of course. And we're not just building new brick and mortar substations with switchgear in it that doesn't take advantage of the new technology, because it will just be grid supplied, obviously. Now, for half the cost, you can produce as much power that's required, additional power, but utilising the renewable technology as well, so we can add in the solar onto grid as well with the battery storage. So it's about the shift in traditional ways of providing more power to a building and having a look at the alternatives. For sure, there's a capex required. I mean, in this particular instance, it's a $3 million project, but at the moment, the only alternative this company in this location has is to pay $6 million, or for the utility company to invest $6 million to provide the additional power to the site. So it's 50% of the current cost that's available today.
Okay, so I'm taking from what you've just said there, really it's about new installation of the largest, where you really get the benefit.
Well, this is not a new installation, this is an existing installation, and the power quality, the power demand on that installation is going up, and the power quality that's there today to be delivered isn't sufficient to allow the growth of that site. So there's either a $6 million investment from the utility company, or there's a $3 million investment from somebody to provide that additional power today.
Thank you. I think we'll just finish with going up the panel. Adrian, I'll begin with you. Just to talk about hardware and software challenges combined. This was really about hardware itself, but can you address that, perhaps?
Well, I think one of the, I wouldn't say challenges, but technology is already there. The hardware itself is equipped mostly with what is required for the software to be integrated into. I really support, actually admire what Chargent is doing, because they've invested a lot in terms of that. Not only on the hardware side, but also being able to manage all those charging stations within New Zealand. Being able to get information, learn from that, do the analytics, and ensure that the service level agreements would be met at a high level.
Let's give ChargeNet a little round of applause since they organised it. And they're obviously invited back. That was really wise. Okay, David, thank you for that. Just hardware and software solutions combined.
I think one of the biggest challenges, well, there's
Or
opportunities,
challenges.
Challenges or opportunities, depending on how you look at them. I try to always turn them around and look at them as opportunities, but the standards on the vehicle and the communications between the charger and the vehicle pose some interesting user interface challenges. For instance, as soon as you plug your CCS car in, the car now knows that the plug's plugged in. There's nothing you do about it. It now starts a charging session. That limits, being able to plug in and walk away, right? Because if you can't start straight away, and then the car charges, times out, and then you have to come back and plug it in later. So those sorts of things are really challenging, maybe they're an opportunity to solve. But and then the communications through those P protocols, the back ends, and integrating with so many different back ends around the world. I think we're up to about 50 or so now, so it keeps growing, and everyone interprets the standards slightly differently, with slightly different, ways and timings and interpretations of how it should be implemented. So that's one of the biggest things, both on the cars and the back end providers. There's just so much going on at once.
I mean, that raises that issue of how you keep up with all of the information that comes at you. It's constantly having to be on top of these innovative ideas.
Yeah, just keep throwing engineers at it.
Yeah. Okay, I'd like to hear now from you, please, Aaron, if you could talk about the challenges of hardware and software.
We've gone from a market where we were just selling dumb chargers all day, every day, with no software connectivity whatsoever, and now the biggest push we're seeing is everybody wants connectivity, everybody wants load management, they want to be able to monitor where people are using these chargers, how they're using them, how they're going to build them internally within the fleet, and I think that's going to be the most important piece moving forward. Again, just shouting out to ChargeNet, their feedback with our vendor Delta, they've been great. They've actually helped develop firmware from what they've found in New Zealand, which has been pushed out to the rest of the world. And so, that software piece is just becoming more and more important as we're moving on with this.
Thank you. Chris, your input.
Just to really confirm this, it's from an ABB point of view globally, if we look back 5 years ago, we look at our top 10 customers globally, the Shell, Z, oil and gas companies. We look at it today, Facebook, Alibaba, all of these technology companies. And the world cannot keep up with the building of data centers today. If you look overseas at what's going on, not so much in New Zealand today, we're connected to other mainlands, but if you look over in Europe and the Americas, what's going on in data center technology and the speed that these things are going up is frightening. It really is. And you can even start to go to the Antarctic and see them get built there now, because one of the biggest uses of a data center is water for cooling. So why not build them in a sub-zero temperature environment so we don't need as much cooling, because it's self-cooling. And these enormous companies are not building these data centers quicker than really the providers can give them for no reason. And it's because we're entering this internet and the fourth industrial revolution, and everything is going to be connected. So we saw it on a presentation before about how many bits of information are going to be required for a smart vehicle in the future. When we look at that for a Boeing 737 or a NASA or whatever it was that we were comparing it against, it's exponential, and that's just an electric vehicle. If you think about that, everything else on planet Earth that's electrical and will be connected starts to give you the idea of the scale of what we're talking about. And that's why the building automation goes so hand in hand with electric vehicle and e-mobility, because everything needs to connect to each other. There's no point in trying to have an efficient electric vehicle at home, charging and running, if you're just wasting electricity to run the home in the first place. Doesn't make any sense.
A great note to end on, because actually it's a metaphor for humans as well. We all need to connect to each other to enhance and amplify these ideas. It's a nice metaphor. So thank you so much, all of the panel, and you will be